Welcome everyone. Thank you for joining us today Minitab webinar. Topic is Minitab Statistical Software, Correlation and Regression. I'm Nausalawati. I'm the Technical Support Specialist at Visit System. Visit System is an independent local presentation for Minitab product and training in Malaysia, Singapore and Batam, Indonesia. Okay, before we get started, there are a few housekeeping items to take note. If you have a question during presentation, please type them into the question box in your control panel. You may send any time throughout the presentation, but I will address them during Q&A session at the end of webinar. But if let's say I don't have any time to answer all the question, I will email to you. Kindly ensure that you have connected to the audio via computer speaker. Please fill up our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. For your information, this webinar will be recorded and therefore it will be set listen only mode to avoid interruption to the audio recording. The recording will be accessible anytime later on our website www.visit.com or by subscribing to our YouTube channel Minitab Malaysia and Singapore. Okay, Minitab, for those are new with us, Minitab actually is the software package for statistical analysis, almost 50 years in market. We are in Minitab, whether you are a statistician or non-statistician, or you are data sciences or non-data sciences, everyone can use because this one is more easy to handle it, simple, less of the dialogue box and so on. Okay, and then we have also features like something like if let's say you are the new or you are also expert in this all the tools inside there, we have something like assistant menu will help you to do it the analysis and then help you in term to interpret the analysis. And now in term of accessibility, now we on the cloud, so everywhere you go you can do it the analysis within the Minitab statistical software. Okay, so this one is example, the tools inside the Minitab we have. For example, if let's say from the quality side, we have a measurement system analysis, something like you want to assess the accuracy and precision in your process. So you can do it something like gauge R&R, and then maybe you are study on the gauge linear and the bias. And then we also cover for the control chart SPC, control chart simply a basic one as bar chart, and then we have advanced like QSUM, ENW, MA, and so on. Also, we have a capability where you want to assess the process, is it capable or not, okay, within your specification limit. So we have a two type representation for capability, whether it's we call it the six pack or you can go for the capability analysis. Okay. And then if let's say you are coming from the reliability engineering, we also have the something like distribution analysis, we have MTBF, we have accelerated live testing and so on. Okay. Also, if let's say you are coming from R&D department, so I think this one is the last month, we have a webinar on this design of experiment. We not only limited for the factor design, we also have the something like response surface. We have a Taguchi, and then inside the design estimate itself, we have a feature something like to have a mean plot. We have the Pareto chart, and then we have the power and sample size. And then nowadays, I think almost all of talk about the big data, talk about the analytics side. So we already have the tools inside the analytics. You can see it. After this, for example, for the correlation today topics, and then we have a new updating 20.2. We have a predictive model, which is the we have a part inside there. We have random forest, we have the tree net inside the predictive analytic model. And then we also cover for something like unsupervised method, also for the multivariate. And then we also have the time series model up to the ARIMA models. Okay, so if let's say you are coming from the process validation, so during the first process validation, we have the process design, we have the process qualification, we have the continuous process validation. So almost all the statistical tools out there available in Minitab statistical software. Okay, so now we currently have new version 20.2 version. Okay. So this one is the some organization already using our software, Minitab Statistical software. For information, Minitab is not only limited to the manufacturing side. We also have various field or various sector. For example, in academician, in services, something like Asia and so on. So they using our software, Minitab Statistical software. Okay, so our agenda today is about the correlation, and then we go for the correlogram. Correlogram is the new updating for Minitab 20.2. If let's say you are using Minitab 20, I encourage you to update, and then you can get know more about the correlogram. And then after we know the correlation between each variable, we can go for the regression. And then after that, I will show how to run it, the regression using the assistant menu button. Okay, some some step during do the something like descriptive statistic, we try looking another thing is something like is correlated pair of variable are correlated. So if let's say you want to study or assess on the correlated variables, you can go for the correlation. Okay, so in correlation tools, you can see the linear relationship between the pair of the variables, and then the strength of the relationship. Is it is low strength or medium strength or high strength between two variables. Okay, and then after we know the between two variables have to correlate each other, so you can use one of the method to model your we call it is a regression, one of the model available if let's say you want to study about the correlated with each variables. And then after you get the best model from the regression model, okay, so you can go for to do the prediction. So that's why we need go for the correlation, and then after know about the correlation, we go for the regression. So both of these those inside here is to do the prediction. Okay. So why we use correlation and regression? For correlation, we want to know about the linearity of relationship, whether is it positive linear or negative linear. And then we want to know about the strength of the relationship. Is it low or high relationship between two variables? Okay. And then after that, we go for the regression. We want to know how important of the x variables, meaning that is a predictor variables, into the y is our response variable. Okay, so maybe from regression also you can get something like prediction. You expect for the y when your x is 20 or when your x2 is 3. So you can do the prediction. Okay. So we go for the first here is a correlation. Okay, so correlation measure the strength and the direction of association between two continuous variables. So if let's say you want to, you don't want to do the regression or modeling. So is it okay to do the correlation? Because correlation is measure the strength and direction of the association between two continuous variable. If let's say your variable is something attribute, so you cannot do the correlation here. Okay, so because just only for continuous variable. Continuous meaning there is a measurement like numerical, something weight, height, or you have a number, something like have a decimal point. So we consider that is one is the continuous variables. So for the correlation, we call it correlation coefficient or R between two variables. This value R is the value between -1 to +1. Okay, so positive correlation indicate the both variable tend to increase or decrease together. And then for the negative indicate the as one increases, the others tend to decrease. The stronger the negative relationship, the closer to -1. Okay, so if let's say you have a one value for R, is it positive or negative? Is we consider that is a strong relationship between two variables. Okay, but in Minitab we have only offer for two methods of correlation. The first one is a Pearson product moment correlation, which is we evaluate the linear relationship between two variables. And then the second method available in Minitab, we have a Spearman rank order correlation. This one is the evaluate relationship involving the ordinal variables. Ordinal variables meaning that is something like you have a more than two response and then in order side. For example, let's say if we have a peak, something like we have a low, medium, high, or something like Likert scale, something like one is a not satisfied, two is satisfied, three is most satisfied. So this one is we can go for the Spearman rank or the correlation to know about their relationship. Okay, so we have a two. Pearson and Spearman rank order, but I think most of us using the Pearson product moment or R correlation coefficient. Okay, so here is example for the how we know our variable are correlated each other. Is it positive or negative or no relationship or non-linear relationship? If let's say you can form one line, okay, one line in the right side, so we consider that this one is a positive correlation. If let's say you can form one side in the left, right, so we consider is a negative relationship. But if let's say your R equal to 0, you have a two condition, whether is no relationship, so you cannot form any kind of the positive or negative linear relationship. So we consider that this one is no relationship. But if let's say you're looking for the R equal to 0, maybe R equal to 0 is we consider that is a non-linear relationship. So beware if let's say you get the result for R 0, so you need go further. We call it here is a scatter plot. Okay, you need to see your scatter plot, whether is referred to no relationship or non-linear relationship. Okay, so if let's say your R equal to 0.1, something like up to 1, so you consider that is positive. If let's say your R if a negative 0.01 to 1, okay, -1, so you consider that this one is the negative correlate. But if let's say your R equal to 0, you need go to the scatter plot to see whether is it referred to no relationship or non-linear relationship. Okay, so I have example here. I think I go to the Minitab directly. Okay, for this are new with us, I think starting with the Minitab 19, we already up to the, we call it the single interface. Okay, single document interface where you can see only one single part in your worksheet, and then your output here. Before that, if let's say you're using the Minitab 17, 18, so the version side, you need have two, we call it multiple interface, where once you create the something like graph, so they pop up another windows. But now we call it is a single interface where all the graph or the output in this output pane. Okay, so basic one, all the our analysis part in the step menu. Okay, and then for your information, let's say because currently we regularly update our version. So I think I need to show how to see your update version. So you can go for the hub, okay, about Minitab, and you can see that this one is the product version. So from here you see, you can know what version you already have. Okay, if let's say you not the latest version, they encourage you to update the version. So you can check for updating. Okay, so but for your information, for the new version is Minitab 20.2. Okay, and then I think all this one are familiar with this one. Okay, so all this in the step menu button. For this case, we want to do something like here. Okay, we want to assess the stiffness of the particle board had the manufacturer user. We have a 30 variables here. We have a density, we have a temperature, and then we have stiffness. So we consider that stiffness is our response. The rest is density, and temperature is our predictor. So we want to assess density with the stiffness, temperature with the stiffness. So which one is have a correlate, the highest correlate? Is it have a negative or positive correlate? So I go to this data set. Okay, you can see that is our data set is a particle board. Okay, so we have a 30 variables here. Okay, the first one is density, temperature, and stiffness. Density is our predictor. We consider that this one is temperature, is our predictor also. Stiffness is our response. So how to get the correlation? So go to start basic statistic. You go for the correlation. Okay, so I will do where to get basic statistic, go to correlation. So which one, so actually in the correlation side, no need to know is it predictor or response, so you can select all this one. Okay, you select and then go for the variables. But for information, we provide the graph or scatter plot. Okay, whether you want to have something like lower left or upper left or full. So just I go for default setting, lower left only, click OK. And then you have the option here. Okay, we have a two, Pearson or Spearman. But here I just proceed with the Pearson, click OK. And then in the result side, we want, if let's say you want to see the P value, okay, so you go for the PWAS correlation table. Okay, and then click OK. And then after click OK. Okay, so they pop up this result in this output pane, we call it. So I go back to basic statistic, go for the correlation. You select all these variables and then you click OK. So you get this scatter plot with the R correlation coefficient, and then they provide also the confidence interval for this one. Okay, so based on this R value, so you can see that density with the temperature is a negative. Okay, meaning that density and temperature have the negative relationship, but it's not so high. Is about the 0.082 only. So you can see that the second one is stiffness and density is the R is almost higher, 0.9, and then this one is a positive correlate. So meaning that now we can see that from this scatter plot, we see that have the correlation between density and stiffness. Okay, but we go for the temperature and stiffness, we see that it's a negative, but the value of the R coefficient also is a less. is so small, 0.004. So we consider that density and stiffness have a more correlate between density and stiffness. But if let's say you want to see about you looking for the p-value, so you can go for the Pearson correlation. So between this one, so this one is the less 0.05, yeah, our alpha value. So you can get that this one is the significance. So between stiffness and density have the correlation. But the other stiffness and temperature is no correlate between each other. Okay, but I think this one is pairwise Pearson correlation is starting with the Minitab. You can get this pairwise Pearson correlation. Okay, so you can build your hash now. Okay, so we go for the next one. Okay, I think I already explained it about this one. Okay, you can see that. Okay, the scatter plot, all this one. Okay, so we go for another tools. We call it parallelogram, but this one is available for the new updating 20.2. Okay, so parallelogram is a visualization that display the correlation coefficient with variables names define the rows and columns. Okay, in the parallelogram, actually they use the color gradient indicate the low and high correlation between each variables. Okay, but this parallelogram is a benefit for you if let's say you have a big data, something like you have almost variables, okay, not the only 2 variable, maybe 20, 30 and so on, so 10 or so on. So you want to see the variety of the correlation between each variable. So they using the color gradient to indicate is it is a low or high. So no need to looking for the R value. For example, before this, for this one, so we see the R value. So from this R value, you need to think, is it low or high, something like that one. But in the parallelogram, you can see the low and high correlate with the color gradient. Okay, I will show after this. So I have one case study here. We have a bank require 8 pieces of information from the loan application. Is the income, education level, our age, length of the time current residence, length of the time with the current employee, saving, debt, and the number of credit card. So 8 variables we have. So they want to know this correlation between 8 variables, which is income versus education level, income versus the age. So this one is applicable if let's say you have a curriculum to easy to see it. Okay, easy to see. I go to the Minitab. Okay. Okay, I go to Minitab again. Okay, which is we have another case study here. Okay, we have another case study here. Okay, where we have 8 variables here. So all these 8 variable is a continuous one. So how to get the parallelogram? So you go for the graph. Okay, go for the graph. Go to parallelogram. Okay, if let's say you have already Minitab 20.2. Okay, so go to graph, parallelogram. Okay, for the variables, you select all this one. If let's say you want, okay, and then in this one, you want to display the correlation values, meaning as your R value, you want to display it, and then you click OK. So now you get the parallelogram. Okay, so we go to a graph, parallelogram, and then you select all this variable, and then you click OK. So you get this one. So in this gradient colors, you see that if let's say the blue color here, meaning there is a negative relationship. Okay, if let's say go for the dark red here, so we consider that this one is the positive correlate between each variable here. So for example here, the highest one, the darkness here is a resident versus the employee. Okay, where the R value is 0.9. 0.95. So I think if let's say you go for this one, so you compare for each this one, you can see it that differences between correlogram and correlation. The same thing but different visualization. This one is applicable if let's say you have more variables inside there to see it, the correlate between each variable. Okay, if let's say you have a simple variable, so you can go for the metric or you can go for the correlation. Okay, so we have a two here to assess the correlation, whether you want to using the correlogram or you go for the correlation only. Okay, so for example here, if let's say you have the correlate between each variable, so you have your own response and then you have your own predictor, which variable is our predictor. So you can see it if let's say have a most uh, correlate between there. So you can form, we call it the models, whether regression or others models. But today we focus only for a regression. Okay. So if let's say you have something like if residents, employee, and then maybe you can add with the age, okay, and employee, and the age with the resident. So you want to form one of the model here, okay, from this correlogram. So today I just focus on the regression only for the model, build the model, okay. So basically, regression is allow the user to model relationship between the response and various predictor. So basically, if let's say in the mathematical model, we have a y equal to b naught plus b1x plus b2 x2 and so on. So regression can be linear. You can form one linear here, or maybe regression can we consider that it's a non-linear relationship, whether you are quadratic relationship or you have a cubical relationship. So both of this quadratic and cubical, we consider that this one is the non-linear shape between response and the various predictor. Okay, so the strong regression model can be used to calculate expected value and to predict the impact of the future changes. So meaning that if let's say now, if let's say you have a y, the new observation for the y x1, sorry, for the x1, so you can predict the value of your y. Okay, so if let's say you have a new data coming with the x2, so you can predict the value of your y. So this one is why we need the model something. For example, regression model. So you can do the prediction for the better future. So, but in the regression inside, we have a lot type of regression. Okay, but the type of regression is depends on the our response, our y. If let's say your y is continuous, so you can go for the simple regression, or you can go for the multiple regression, or you can go for the non-linear regression, or you can go for the partial least square. So continuous, as I mentioned, this one is a measurement, something like length, weight. So if let's say you assess your y, only you have your x only one, so you can go for the simple regression. If let's say your x now, your predictor more than one, you can go for the multiple regression. If let's say your scatter plot, during you do the scatter plot, you can see that it's a non-linear shape, so you can go for the non-linear regression. And then if let's say you go for your predictor, each predictor have a real correlate between there, so you can go for the partial least square. Okay, but today I just play around with the multiple regression. And then if let's say your y, your response now is the binary, is have a two, accept or reject, fail, go or no go. So you can go for the binary logistic regression. If let's say your Y ordinal, something like low, median, high, so you can go for the ordinal logistic regression. If let's say your Y is something like nominal, something like low, high, median, so you can go for the nominal. If let's say your Y is even or outcome, okay, probability, so you can go for the Poisson regression. And then for your information, all this one is available in Minitab. Okay, so where is go to stat, go to regression. So you can see it, the fitted line, which is the simple regression. If let's say you have only one X, if let's say you go have a more than 2x, more than 2 predictor, so you can go for the fit regression model. If let's say you see it from the scatter plot, you can go for the non-linear model. Okay, so you can go for the partial least square, or you can go for the stability study. So we have a binary, okay, we have a ordinal, we have a nominal, we have the Poisson regression. But I just want to see it here. Even we have a lot type of regression, the objective with the regression is the same, stay the same. We want to do the prediction. The method with the prediction regression is different when your Y is a different type of data. Is it continuous or descriptive? Okay, but the purpose with the regression is the same, is to do the prediction. Okay, so here is something like simple step to read the regression. The first step, you need to choose the type of regression analysis. So this one is depends on your type of response or your target or your Y. And then you need to have a specified regression model, which is you want to consist determine which predictor variables to include in the model, whether you need to model curvature, which is nonlinear, and interaction between the predictor variables. So for the specified regression model, actually from the correlation, you can see it. Is it X1 have a correlation between your Y, or is it have a correlate X2, X3, and so on. So from there, you can do it the specified regression model. No need to include all the variables. Okay. And then we go for the third step, which is you do it the analysis, you need to interpret. So we looking for the regression coefficient and the p-value for each correlation, something like x1, x2. We go after this is from the ANOVA table, and then we're looking for the R squared. We have three type of R squared. We have adjusted R squared, and then we have the predicted R squared. Okay, so all this R squared is to see it how well your model, how well or how percentage your variation in the response that explain it by the model. So we're looking for the R squared. Maybe you don't want using the R squared, you can go for the adjusted R squared. If let's say you want to looking for the predicted R squared, or you want to do the new observation, for the new observation, so you can go for the predicted R squared. But today I cannot give it you when to using the R squared, when to using the adjusted R squared, and when to using the predicted R squared. Okay, if let's say you want to know more, you need to join our training for me regression topic. Okay, so the first step is a check assumption. Okay, this one is the regression. Because regression is statistical model, so you need to check your assumption. So we need to check the residual, whether is a normal. You can see it, the residual, is it to follow a straight line? So we consider that is a normal distributed. The second one is you need to assess, is it the constant variance or for other fitted value? So let's say the third one, you need to see it the random over the time. Is it the plot so far randomly around the center line of zero? Okay, and then after that, the last step, sure, is make the prediction. The response variable change when you change the value of the predictor variables. So make sure we have a 8-step here. The first one, you need to choose which type of regression you want to using based on the response, and then you need to specify the regression model. You need to specify your model which predictor you consider that is have correlate with your response, and then you need to interpret whether is your R squared, is it higher or lower, and so on. And then after that, you consider that this one is okay with the R squared, so you need to assess the assumption, the residual. Is a fulfill this assumption, and then you go for the prediction. Okay, and then here I have one case study here. Okay, energy usage commission encourage a manufacturing plant to keep monthly energy usage below 1 million for the each kilowatt above this one. And this is one to develop a statistical model to identify the major sources of energy usage, and it's to develop guideline for monthly equipment users. They begin by consider the following predictor. So the first predictor is total unit produced, total equipment runtime, employee hours, mean outside temperature, minimum outside the temperature, maximum outside the temperature, percentage of sun, and the mean equipment age. So I think I go to that data set, easy to see it. Okay, so I have the plant energy here. So which is now we have the, our energy is our Y. The rest of this one, not include the months, only from the mean temperature, mean average temperature, minimum temperature, maximum temperature. We have percentage, we have unit. This one is we consider is our variables. Our predictor. So this one is our response, BR, our Y. This one is, consider that this one is X1, X2, and so on. Okay. So how to run it, the regression? So you go to the stat, okay? So go to stat, and they see the energy is a continuous data set. So meaning that now you're using the multiple regression, okay? So go to stat, go to regression, and then you choose fit regression model. Okay, I will go to stat, go to regression. You choose fit regression models. So in our response, so BR energy. So our continuous predictor is starting from the mean up to the average equipment age. Okay. And then, of course, we go for the graph to look in the assumption here. Maybe you want to see the effect of the plot. Click OK, and then click OK. Okay, sorry for this one. Okay, so now you get the regression analysis. So I will do, go to stat, go to regression, you choose fit regression models. So inside the response, you need to choose your response, you need to choose predictor, and then you go for the graph. Okay, and then click OK, and then you click OK. So you get the regression. So inside the regression side, we need to looking for the model summary first. So based on this R squared, is quite higher, 99.60 percentage, 99% is quite high. Okay, so meaning that is now the percentage of variation in the response that is explained by the model is about the 99%. Okay, it's quite okay. And then after that, we're looking for the p-value here. Okay, p-value, is it this one significant or not significant? So based on this equation, you can see it that almost all these predictors are significant because they include in this equation. So it's not so easy to explain it, is it? So that's why we need go for, we call it refit the model. Okay, because you need to access all this one, all this predictor. The main, we want to know which predictor are more effect to the energy. So meaning that now we need to refit our model. Okay, we refit our model. So go to the dialog box again, which is we have in the Minitab, we call it stepwise. Okay, stepwise, which is we have something like you want to have only the last model. Okay, final model be adequate model to you. No need to see it the others thing. So you can go for the method. So you can see it. We have a stepwise. We have a forward selection. We have backward elimination. We have forward information criteria. We have the forward forward selection with validation. I think I have this information. Okay, so this one. Okay. So during the model selection, we have automate selection. We have a 3 common procedure, which is we're looking for the criteria for the p-value, and then the second one, information criteria for the fit. We have ICC and BIC. ICC, which is we call it a kind information criteria. For the BIC, we call it the bias information criteria. And then we have another more selection, okay, type. We have a R-squared value for predicted fit of the model. This one is we just only added on the Minitab 19.2. I think if let's say you have a 19, so you need to update to 19.2, and then you can see it, the K4 validation with the test set for selection, and then you can see it this kind of in the dialog box. If let's say you update to 19.2, I think. Okay, as I remember. For this one is ICC, BIC. I think most academicians using this criteria to get the final model. And then I think most of us using the stepwise or forward selection or backward elimination. For this case, we go for the stepwise regression only. Okay, so we just go back to this dialog box. So we go for the stepwise. Okay, so we choose stepwise. Okay, so this one is the default setting here is 0.15. So depends on you. If let's say here we always using the 0.05. Okay, so you get this one, and then you click OK. You click OK. Okay, so now you're using the stepwise model. So you can see it that now only the significant predictor in your regression. Okay, just only 2, maximum temperature and total equipment runtime. Okay, so if they help you to get the final model. Okay, stepwise. So I will go to this one, go to stepwise. You choose stepwise, and then you click OK. After that, you click OK. So you get the regression equation here. So this one is the first we do it, the regression. So you see it that this one is our regression equation without eliminate any predictor. Okay, so now they in stepwise procedure is something like they eliminate the p-value. Okay, based on the p-value is, let's say they eliminate by add or remove the predictor one by one at a time. Okay, so this one is more easy to see it. Only 2 predictor are significant. So based on this coefficient also only are significant based on the p-value less than 0.01. Okay, so no worries if let's say you want to do it one by one, it can. Okay, no need to using the stepwise, but I think most of us have something like don't have any time
to do it one by one. So you need go for the stepwise. You need to using the stepwise to help you find out the last model. Okay, if let's say here you see that the model summary is quite the same thing. Okay, the same. Okay, almost 99% is quite higher. And then after that we go for the this one. Okay, this assumption. Okay, because regression is the statistical models, so you need to go for the assumption, looking for assumption. So based on this residual plot is a normal residual, and then here is a constant, which is not on this one, and then based on the versus order here is almost around this one is over the time. So all these assumptions are fulfilled, and then you can accept this equation be are the best model. From this equation, you can do the prediction. Okay, so that's why the how we using the Minitab to run the regression. Okay, you get this equation. Okay, because the best model is the simplest model. Simplest model meaning that is less number of our predictor. Okay, the simplest model is the less number of our predictor. So the regression equation indicate the higher energy usage when the maximum temperature is high. Okay, the total equipment run is the height, and then average equipment is the height. So all this one is the height. Okay, when all this height is the maximum, indicate the higher energy. Okay, so from here, from this one, you check your assumption. All the assumptions are met. So you can go for the prediction. Okay, you can go for the prediction. Now, if let's say you have a maximum temperature, 77.65, your total equipment you run is 2996, and then your average is 79.2. So what is your energy you can do? Okay, so all this one is available in Minitab. Okay, so once you already have the model here, so you go back to stat, you go back to regression, you see that now they have you can run it with the predict, or you can run for the factorial plot, you can go for the counter plot, you can go for the surface plots, and so on. So here we can do the prediction. Okay, so whether is it the prediction, okay, the prediction is maximum, maybe, okay, maximum, okay, temperature is 17, maybe, okay. So here is something like 799, okay, and then you click OK. So they give it the setting here, the fit. So with this setting, your maximum temperature is 77, and then the total equipment run is 79. So your energy, predicted energy you is 11095.9. And then if let's say you want to looking for the confidence interval, so you can get the confidence interval for the fit, or you can get the predictor interval for the fit, this one. Okay, so this one is how regression, you build the regression. Okay, you get the best model. Okay, from this best model, you do the prediction. Okay, you do the prediction. So I think this one is system. So another step, you can run the regression using the assistant menu. So in the assistant menu is, I think this one is have a pick appropriate statistical tools, ensure your success with the analysis. You can run analysis quickly and easily. You can interpret your result with confidence because we provide the summary report, we provide the variation report, and we have the report card. And then easy to share your finding with the one click. So I will show how to run it in assistant. So in assistant, actually we have the regression. Okay, but not all the in the stat menu tools available in Assistant. Most of the frequent tools inside the step menu, we have in Assistant menu. Okay, Assistant menu, this one is something like I choose the regression here. Okay, so you see it that they have a number of variables. If let's say you have a 1x only, so they give it you, go for the simple regression. If let's say you have more than 2, or but for this case, for Assistant, just only up to 5 variables only, up to 5 variables only. Okay, if let's say you have a 6 variable, so you're not able to using the Assistant menu. So you need to go for the step menu, conventional step. Go for the step menu. So for the Assistant menu, for regression only have applicable if let's say only up to 5 predictor. Okay, if let's say you have 6, you need go for the step menu button. And then here, if let's say you don't consider what is the 1 variables, what is the 2 or 5, so they give it you the explanation, the information before you get further. Okay, so I think I have another case study here. It's about the knock. Okay, I have this one. Okay, so consider that is an our not is the response. The rest is our predictor. I have 4 predictor here. Okay, I have 4 predictor and then I have 1 response. So I go to Assistant regression. So now I have a 4 this one. So I need go for the multiple regression. So I choose multiple regression is our node. Here is the spot. Click OK. And then click OK. Okay, so you get the this one. I go back, Assistant, go to regression. Since I have 4 predictor, so I go for the multiple regression. I complete all this telebot and then click OK. And then click OK, and you get the Assistant. So here is we call it summary report. I think most of our customer love using the Assistant because this kind of the graph here. Is it the relationship between Y and S variable? Has yes. Okay, and then how many explain it is your R square here. Okay, R square is a certain one. And then the comment here, which is part and AFR predictor is a significant to our response. So in this one, okay, they give it you another features we have. If let's say the gray color is not significant into, so not significant meaning that it's not include into your equation. Okay, so only have a spot and then AFR. Okay, so you can see that this one is the diagnostic report. Is a low pattern, you can see the larger residual, and then you have the final model here. Okay, you can see the final model here is your Y equal to 99.73 minus 1.854 x1 plus with 0.880 x4. So all this one, and then they have a report card here. Is it they see it the how data set, how many data set we have, okay, and then they looking for the unusual data point or outlier data point, because for information, a regression is sensitive to the outliers. So you need to care outliers first before you get the best model here. Okay. So you need to sure that this thing, all this one. Okay, so today we go for the correlation. What is correlation? Is want to know about the relationship between variables, continuous variables. If let's say you have more variables, you can go for the correlogram. If let's say you already know about the relationship between each variable, each predictor, so you can go for the modeling with the regression. So we want to the simplest model. So you need maybe you can using the stepwise models, and then after you get the best model, you want to the prediction. Okay, so we have an alternative also to the regression with the assistant menu button. Okay, so this one I already think. This one. Okay, so I think apply the correlation and regression analysis can be a great decision-making tools because you can predict the average outcome given the input value. And then we go for the Q&A session. If let's say you have question, you can type into the question box. If let's say I don't have any time to answer it, I will email to you privately. Okay, so I go the first. Okay. Okay, I think if let's say you see it, the best R squared. What is the best R squared? Most of the industry using the 70% is the best model. So if let's say below than 70% is not good model. If let's say you get the above 70%, your R squared, we consider that is a good model. Okay, but if let's say you have 80%, 90% is quite good, already good one. Okay. Okay, regression PRS, when we can apply it. Okay, so actually for the partial least squared, if let's say your predictor have a correlate each other. For example here, I think I not touch it on this portion. Okay, and not touch on this portion. This we consider if let's say you're using the regression side, you can see it the VIF. If we call it in term technically, we call it this one is the multicollinearity, which is the value of the correlate between each predictor. In the regression side, we want to see it the correlation between predictor and then our response. Not the one to see it the correlation between the predictor. Okay, if let's say you have this kind of this one, you can see it the your VIF here. We have other method to avoid this thing. Okay, so for this multicollinearity, but I doesn't have enough time to catch up for this kind of the multicollinearities. But in the Minitab available, if let's say you want to looking for the multicollinearity, you can go for the VIF here. Okay. Okay, for your information, if let's say you have more than one Y, actually is available. So you can see it, the response here. You can see that the dialog box for the response, you can include all this one or how many response you have, but the equation give it to you one by one. Okay, not the something like they Minitab not able to optimize which Y. Okay, they provide the Y here. Okay. If let's say you want this, if let's say you want this material, you need to drop your email whether in the Q&A session or in chat box. Okay, whether in the chat box. Okay. Almost for the R correlation coefficient almost there, almost R 0.7, we consider that have higher correlation between two variables. Okay, between two variables. Okay, actually we have a training site, but you need to go to our website to see it when this training are available. Okay. Is there okay? This okay, if let's say you want this material, you need to drop your email and I will email to you after this. Okay, if let's say I not enough time to see it all these questions, I will email to you after this. I will try email to you after this. Okay, hopefully you get something from this webinar. Okay, thank you for joining us today. If let's say you want to get know about us, so you can visit our website www.minitab.com or www.visit.com, or you can contact us or email us if let's say you want to know about the training part, and then for the license and so on. So you can email to us. So sales@visit.com or minitab@visit.com. And then please follow us in the media social like Facebook and link to get more about us in terms the when our next webinar, when our next workshop, when our next training and so on. And then what is the new updating from the Minitab statistical software. So please follow us in the Minitab Malaysia and Singapore through the Facebook and link. And then we have service like training, statistical consulting, and support the software itself. Okay, so thank you guys, and then maybe see you again with different topic in the next month. Stay safe.